Function is the correspondence from a set of real numbers x to a set of real numbers y, where the number y is unique for a specific value of x. A function is a set of ordered pairs of real numbers in which no two distinct ordered pairs have the same first number. So we have x as the independent variable and y as the dependent variable from the function notation y equals f of x. Domain is a set of all admissible values of x and range is the resulting values of y. Examples of functions are: a factory's total production may depend on the number of machines used. A person's salary may depend on the number of hours worked. A fixed length electrical cable's resistance depends on its diameter. We have 4 ways to represent a function. It is by verbally, numerically, graphically, and algebraically. A graph if it is a function by using the vertical line test. The graph of a function can be intersected by a vertical line in at most one point. So having a parabola that opens to the right with x equals y squared, so the vertical line intersected the graph at 2 points, it is not a function of x. Another parabola that opens upward, which is y equals x squared, so it is a function of x for the vertical line intersected it at 1 point. And then we have y equals the absolute value of x, it is a function of x. And another graph which is y equals x cubed is another function of x. So the function notation which is y equals f of x was given by Leonhard Euler. So we can now classify the functions. We have algebraically, which would be for polynomial, radical, and rational for the algebraic functions. We have the trigonometric functions, the sine, cosine, tangent, and other functions, and the exponential and the logarithmic functions. So for the operations of functions, we have 4: the sum, the difference, the product, and the quotient. The composite functions now would be f of g, and that would be equal to f of g of x. We could also get the zeros of a function by equating f of x to 0. We can now identify if the given function is even or odd. Getting now f of negative x, which is equal to f of x, the given is even. Evaluating f of negative x leading to negative of f of x, then the given is odd. So if of negative x is not equal to f of x, and f of negative x is not equal to negative of f of x, then the given is neither even nor odd. Solve some functions. So given f of x equals x cubed negative 5x squared plus 7x minus 3. Find f of 0. So the given value is 0. If the given is x, these are all x. But if the given is 0, we will substitute the value of 0 for all the values of x. So given x cubed, we have 0 cubed, negative 5, 0 squared, plus 7 times 0 minus 3. Okay, so the value of this now is negative 3. Let's have another given. So f of negative 2. So substituting negative 2 for all the values of x. So we now have negative 2 raised to 3, negative 5 times negative 2 squared, plus 7 times negative 2 minus 3. So the result of this now is negative 45. Another function is f of 8. So we have 8 raised to 3, negative 5 times 8 squared, plus 7 times 8 minus 3. So if we're going to evaluate this, the result would be 245. So moving on, we have f of h squared. So instead of x, we will be having h squared. So this is now h squared raised to 3, negative 5 of h squared squared, plus 7 of h squared minus 3. So what would now be the value of this? H squared raised to 3, that would be h raised to 6. Then h squared squared, that would be h raised to 4. So negative 5 h raised to 4 plus 7 h squared, then minus 3. Let's evaluate f of x cubed. We have x cubed raised to 3, negative 5, x cubed raised to 2, and then positive 7 times x cubed minus 3. So what would now be the evaluation of this function? We have x cubed raised to 3, that would be x raised to 9. Then negative 5, x raised to 3, and then raised to 2, so that would be x raised to 6. Plus 7, x raised to 3 minus 3. So those are some examples for the evaluation of functions. So let's have one more evaluation. We will be getting the value of f of x plus delta x minus f of x over delta x. So you will be using this formula in the limit process in getting the derivative and then applying the limit process. Okay, but for the meantime, we'll just be having the function of that. So we need to get now f of x plus delta x. So it means all the values of x would become x plus delta x. So what would be our given? We have x cubed minus 5x squared plus 7x minus 3. So instead of x, we'll be having x plus delta x. So what would be our value now? So x plus delta x raised to 3. And then negative 5x squared. So negative 5 x plus delta x squared. And then after that, positive 7x. So 7x plus delta x minus 3. So this is the value of f of x plus delta x. And then we have to subtract the given f of x. So the given f of x is x cubed negative 5x squared plus 7x minus 3. And then after evaluating the numerator, we will be dividing the given by delta x. So we have to expand first this one in order to simplify. Okay, so what would be our expansion? For the first value, x cubed plus 3 x squared delta x plus 3x delta x squared plus delta x cubed. This is the expansion of the first one. Minus 5, and then we have to expand this one, that would be squared. X squared plus 2x delta x plus delta x squared. And then plus 7, we can now distribute 7. So 7x plus 7 delta x. And then minus 3. We could also distribute the negative sign. So negative x cubed, negative and negative, that would be positive 5x squared, and then negative 7x positive 3. So all over delta x. Okay, so let's now evaluate this. And then we will simplify all the given that would be positive and negative. Let's rewrite first. X cubed, 3x squared delta x plus 3x delta x squared plus delta x cubed. And then distribute negative 5. Negative 5x squared, negative 10x delta x, negative 5 delta x squared plus 7x plus 7 delta x. Negative 3, negative x cubed, positive 5x squared, negative 7x plus 3. So let's now look at our given because we will be simplifying the numerator over delta x. X cubed, negative x cubed, so that would become 0. And then followed by negative 5x squared, positive 5x squared, another 0. Positive 7x, negative 7x, and then negative 3 and positive 3. So the resulting value now is 3x squared delta x plus 3x delta x squared plus delta x cubed. And then negative 10x delta x, negative 5 delta x squared, and then positive 7 delta x, and this is all over delta x. So after evaluating the numerator, we will now divide each value on the numerator with delta x. Okay, so this would become 3x squared plus 3x delta x squared over delta x, that would be delta x. And then delta x cubed over delta x, so delta x squared. Then negative 10x And then negative 5 delta x positive 7. Okay? So this would now be the value of the given function. So find the values of x for which f of x is equal to g of x. Okay, so we have f of x and g of x. So the given f of x is equal to x squared minus 1. And g of x is equal to negative x squared plus x plus 2. So we will be getting f of x equals g of x. So we will now equate the given. So f of x, that would be x squared minus 1 equals g of x negative x squared positive x positive 2. So let's transpose all the variables, all the given polynomials on one side. So let's transpose this. This is negative, it would become positive. So x squared minus 1 positive x squared, then transpose that, negative x, negative 2 equals 0. So we have 2x squared, and then negative x, and then negative 3 equals 0. So we will now factor out. So what would be the factors? So we have 2x squared, so 2x and x, and that would be equal to 0. And then we will be needing a value which is 3. So what are the factors of 3? We have 3 and 1, in which we will be getting negative 1x on the middle term. Okay? So let's have negative 3, and then this will become positive 1. Let's check. 2x and x, 2x squared, positive 2x, negative 3x. So that would lead to negative x, and then negative 3 and negative 1. Negative 3 and positive 1, negative 3. So the first value is 2x minus 3 equals 0. Transpose negative 3, it would become positive 3. And then divide both sides by 2. So the value of x is positive 3 over 2. And then the other factor is x plus 1 equals 0. Transpose 1, so we have negative 1. So these are now the values of x in which f of x equals g of x. So we have negative 1 and positive 3 over 2. So, using the same given, like this one, the given on our first example. So, using the same f of x and g of x, determine f plus g of x. So we will be having the operations of functions. F plus g of x is equal to f of x plus g of x. So let's write f of x, it's x squared minus 1 plus the value of g of x, it's negative x squared positive x positive 2. So what is now the result? X squared minus x squared, that would be 0. So positive x, negative 1 plus 2, so that would be positive 1. So this would fall under the addition. So that would be the sum of functions. Let's have now the difference of two functions. So we have f of x minus g of x, which could also be written as f minus g of x. So f of x, x squared minus 1 minus g of x, negative x squared plus x plus 2. So this would become x squared. Let's write that. X squared minus 1, negative and negative. So positive x squared, negative and positive, negative x, and then negative and positive, negative 2. So let's simplify that. X squared plus x squared, that would be 2x squared. And then negative x, negative 1 minus 2, negative 3. So this is the result for the sum, and then this would be for the difference. So the third one would be the product of the two functions. So f times g of x. So f of x is x squared minus 1, and then times g of x, negative x squared plus x plus 2. So we will be using FOIL method. So let's distribute. X squared and then negative x squared, that would be negative x raised to 4. Positive x cubed, and then positive 2x squared. And then followed by negative 1 times negative x squared, so positive x squared. And then negative x and negative 2. So we will combine this given. So what would be the result? Negative x raised to 4, positive x cubed, and then 2 plus 1, that would be 3. 3 x squared, negative x minus 2. One more operation for the functions is the division. So let's now have f over g of x. So which is f of x over g of x. Okay? So f of x over g of x. So what would be the value? X squared minus 1 over negative x squared plus x plus 2. We can factor out x squared minus 1. So by x plus 1 and x minus 1. And then, how about this one? Factors of x squared, we have x and negative x. Factors of 2 would be 2 and 1. So we have x plus 1 and then negative x plus 2. Let's check. This is negative x squared, positive 2x, negative x, so that would lead to positive x and then positive 2. So we can now cancel out x plus 1 and x plus 1. So which would lead to x minus 1 over negative x plus 2. But don't forget, this is still improper, so we can still divide that one. So let's divide that. What would be our value now? We have x minus 1 divided by negative x plus 2. So x divided by negative x is negative 1. So negative 1 times negative x is positive x. Negative 1 times 2, it's negative 2. And then perform subtraction. So this would become negative. This is negative. It would become positive. So what would be the value now? X minus x is 0. Negative 1 plus 2. So that would be a remainder of 1. So the final value now is negative 1 plus remainder, that would be 1 over negative x plus 2 or 2 minus x. And this would be the result for the division. So let's have composite functions using the same value for f of x and g of x. So let's rewrite. F of x is equal to x squared minus 1. And then g of x is equal to negative x squared plus x plus 2. When we say g of x, so g of x is equal to f of g. When we say f of g is equal, this is equal to f of g of x. So from our given function in our previous example, if the given, let's say with this one, if the given is negative 2, then we will substitute negative 2 to all the values of x. So now, instead of negative 2, the given is g of x. So we will substitute now to all the values of x the value of g of x. So let's use the value of f. F is x squared minus 1. So we have x squared minus 1. But now, what is the value of x that we're going to use? It would be from g of x. And g of x is negative x squared plus x plus 2. So since this is squared, we have to evaluate that. So what would now be the evaluation of that if we're going to have that? So we will be having x raised to 4, negative 2x cubed, negative 3, x squared plus 4x. Okay? And then plus 4. So that is the expansion of this. And then don't forget you have negative 1. So the result now is x raised to 4, negative 2x cubed, negative 3x squared plus 4x, 4 plus minus 1, that would be positive 3. So this is now f of g. So it's the same with g of f. So g our function, and then f would be the values of x. So the value now of g is negative of x squared plus x plus 2. So what would now be the value of x? It would be coming from f of x. And f of x is x squared minus 1. So this is also x squared minus 1. So let's expand. Negative of x raised to 4 minus 2 x squared plus 1. And then positive x squared minus 1 positive 2. Let's distribute the negative sign. Negative x raised to 4 positive 2x squared negative 1 positive x squared minus 1 plus 2. So let's simplify. We have negative x raised to 4. And then this will become positive 3x squared, negative 1 is negative 2 plus 2. So that would be 0. So this is now g of f. If we're going to talk about functions, we could also determine if the given function is even, odd, or neither. So let's have the first one. F of x equals 3x raised to 4 negative 7x squared plus 5. So we have to determine if it is even, odd, or neither. So we will now be evaluating f of negative x. So we will be using negative x for all the values of x. So we have 3 negative x raised to 4 minus 7 negative x squared plus 5. Negative x raised to 4 is x raised to 4. So we have 3x raised to 4. Then negative 7. This is negative x quantity squared. So that would be positive x squared. So negative 7 x squared plus 5. Now looking at the given, they are the same. And don't forget, this is f of x, f of negative x. So f of negative x now is equal to f of x. So if they are equal, then the given function is even. So with the next one, we will evaluate g of negative x. So the given is x raised to 7. So negative x raised to 7, negative 6. So negative x raised to 5 plus 4. Negative x raised to 3. Then negative 2. X would be negative x. So negative x raised to 7 is negative x raised to 7. Negative x raised to 5 is negative x raised to 5 times negative 6. So positive 6 x raised to 5. This is negative x cubed. So negative 4 x cubed. Negative and negative, positive. So positive 2x. So let's look at the given. The given is positive x raised to 7, negative, and then positive, negative. So they are not equal. F of negative x is not equal to f of x. So let's try factoring. So with this given, g of negative x is not equal to g of x. So definitely it is not even. Okay? So let's try factoring the negative sign. So negative of, this would become positive x raised to 7. This is positive. It would become negative 6 x raised to 5. Negative, so positive 4 x cubed, and then negative 2x. So this is negative, and then this is the given for g of x. So with this, and this is g of negative x. So g of negative x is equal to negative of g of x. Okay? So the given is add. Now if in case that the given, let's say the given would be g of negative x is not equal to g of x, and it is also not equal to negative g of x, then the given is neither even nor add. Let's solve now for the domain and range of a given function. So with this given, y equals square root of 16 minus x squared. So we will be getting the zeros of the polynomials. So let's equate this to 0. So square root of 16 minus x squared equals 0. And then square both sides. So we have 16 minus x squared equals 0. Transpose x squared on the other side, we have x squared equals 16. So x now would be positive and negative 4 because x equals the square root of 16 and it is a square root, so we'll be having two values, positive 4 and negative 4. So now we already have these values. Let's try if they are included in the given. Okay, so at x equals positive 4, we will substitute 4 to the given. So y equals 16 minus 4 squared. So this is 0. So it means that positive 4 is included in the domain. At x equals negative 4, so y equals square root of 16 minus negative 4 squared. This is also 0. So also, negative 4 is included in the domain. So let's use the intervals and check if the given interval would be included or not. Okay, so let's have some intervals. So from negative infinity to negative 4. And then negative 4 to positive 4. And then positive 4 to positive infinity. So let's have some values of x that would represent this interval. Let's say that would be negative 5. In between negative infinity and negative 4, so we choose negative 5. In between negative 4 and positive 4, so we can use 0. We can use negative 1, positive 2. 4 to infinity, so let's say that would be 6. Now, we will get the value of y, which is the square root of 16 minus x squared. So, what would now be the value when the given is negative 5 for x? So, we have 16 minus negative 5 squared and then get the square root of that. Okay? So, the given is undefined. So, if it is undefined, so it means it is not included in the given domain. So how about if the given would be 0? So we have 4. 4 is a real number, so this is included. Next, if the number would be 6, so again, this is undefined, so not included. So if we're going to check this one, this interval will only be the included interval for the domain. Now with this, we didn't include 4 and negative 4, but we already checked that positive 4 and negative 4 are included. So let's now write the domain for this. What would be the domain? This would be undefined. Undefined, we cannot have a domain for that. So what would now be our value? So it would just be in this given. Okay, so what would be our interval now? So what would be our domain? The domain now would be from negative 4 to positive 4. Then we will be using square brackets because they are included. Okay, so how about the range? If you're going to have this one, what would be the range now? Okay, so since it is a square root, if we're going to use 4 here, we'll be having 0. And 0 is included. If we're going to use some values, let's say we'll be having, this one will be having negative 3. What if the value would be negative 3? So we have 16 and then negative 3 squared. So that would be a value of square root of 7, which is 2.65. If we're going to use 0, then that would be 16. Square root of 16, that would be 4. So the range now would be from 0 to 4. Find the domain and range of y equals square root of x squared minus 144. So again, let's get the zeros of this polynomial. So square root of x squared minus 144 equals 0. And then after that, square both sides. We'll be having x squared minus 144 equals 0. So transpose negative 144, we have x squared equals 144. And then get the square root of both sides. So the values of x now would be positive and negative 12. So let's check if positive and negative 12 would lead to real numbers for the values of y. So at x equals positive 12, we have y equals the square root of 12 squared minus 144. So this is equal to 0. So positive 12 is included. At x equals negative 12, y equals the square root of negative 12 squared minus 144. So another 0, so included. Let's use the interval method. Okay, so in order to know if the given interval would be the domain or not. So since the given numbers would be negative 12 and positive 12, so let's have negative infinity to negative 12, negative 12 to positive 12, and positive 12 to positive infinity. And then, use some values of x. So let's say this is negative 14. I'll be using 1. And then 12 to infinity, let's say that would be 15. Then solve for the values of y. So the given is the square root of x squared. So we will be using negative 14. And then minus 144. So what would be the value of that? So 2 square root of 13. 2 square root of 13 is a real number. Okay? So if it is a real number, then it is included. So this interval is included. So what if we want to use positive 1? So it is undefined. So the values from negative 12 to 12 would be undefined. But don't forget, included would be 12 and negative 12. But within that, let's say negative 11. Okay, or positive 11. They are not included. And then another, so would be 12 to positive infinity. So we will be using 15. So we have positive 9. So this interval is included. So with that, we have two intervals. So let's now write the domain of the given. So what would be the domain? We have negative infinity to negative 12. But we will be using square bracket for 12 negative because negative 12 is included. With the union of positive 12 then to positive infinity. And for the range, if we're going to use, for these values within this interval, if we're going to use 12, this would become 0. If we're going to use 13, that would lead to a higher value than 0. 14 and so on. So let's say we'll be having 100 for the value of x. Then we'll be having a higher value. So the range now would be from 0 to infinity. And don't forget that infinity would just be a representation of number. So we are using parentheses for infinity.
Lesson 1. Functions and limits. Limits and related theorem. The concept of limits is fundamental in the study of calculus. The limit of a function describes how a function behaves as the independent variable gets closer to a certain number. Consider the function defined by y, the dependent variable, equal to f of x, equal to 4x plus 5, and assign some values near to x but not equal, say, 2. When x is equal to 1.7, substituting 1.7 in the given equation 4x plus 5, then y is equal to 13.8. When x, again, the independent variable, is equal to 1.8, y is now equal to 14.2. Substituting 1.99, y is 14.96. When x is 2.05, y is 15.2. And when x is 2.1, y is 15.4. And finally, when x is 2.2, y is 15.8. Hence, the limit of 4x plus 7 as x approaches 2 is equal to 15. Thus, we define the limit of a function as follows. Let f of x be any function and let a and l be any real numbers. if we can make f of x as close to L as we please by choosing x sufficiently close to a, then we say the limit of f of x as x approaches a is equal to L. Laws of limit. Suppose that c is a constant and the limit of f of x as x approaches a and limit of g of x as x approaches a exist, then number 1. The limit of the sum is the sum of the limits. The limit of f of x plus g of x as x approaches a is equal to the limit of f of x as x approaches a plus the limit of g of x as x approaches a. Number 2. The limit of the difference is the difference of the limits. The limit of f of x minus g of x as x approaches a is equal to the limit of f of x minus g of x as x approaches a. Number 3. If c is a constant, say c is equal to 7, the limit of c of f of x as x approaches a is equal to c multiply the limit of f of x as x approaches a. Number 4. The limit of the product is the product of the limits. The limit of f of x multiply g of x as x approaches a is equal to the limit of f of x as x approaches a multiply the limit of g of x as x approaches a. Number 5. The limit of the quotient is the quotient of the limits. The limit of f of x over g of x as x approaches a is equal to the limit of f of x as x approaches a over the limit of g of x as x approaches a. Another loss of limit, number 6, the limit of quantity f of x raised to n as x approaches a is equal to the quantity, the limit of f of x as x approaches a raised to n. Number 7, the limit of the constant c as x approaches a is equal to the constant c. Number 8, the limit of x raised to n as x approaches a is equal to a raised to n. Number 9, the limit of the nth root of x as x approaches a is equal to the nth root of a. Number 10, the limit of the nth root of f of x as x approaches a is equal to the nth root of the limit of f of x as x approaches a. Next, indeterminate form. An indeterminate form is an expression such as 0 over 0. From the form alone, it cannot be determined. Example, the limit of x minus 1 over x squared minus 1 as x approaches 1. This is indeterminate because if you substitute 1 in the numerator, x minus 1, substituting 1, so 1 minus 1 is 0. In the denominator, 1 squared minus 1 is still 1 minus 1, and 1 minus 1 is 0. 0 over 0 is indeterminate form. Later, I will show you how to solve problems if you have an expression that is indeterminate. Let us continue with squeeze theorem. If h of x is less than or equal to f of x is less than or equal to g of x when x is near a except possibly at a, and the limit h of x as x approaches a is equal to the limit of g of x as x approaches a is equal to L. Then, the limit of f of x as x approaches a is equal to L. Squeeze theorem. The limit of sin x over x as x approaches a is equal to 1. Number 2. 1 minus cosine x, for the limit of 1 minus cosine x over x as x approaches a is equal to 0. For infinite limits, you have 4 equations. Number 1. The limit of 1 over x raised to r as x approaches positive infinity is equal to 0. Number 2, the limit of 1 over x raised to r as x approaches negative infinity is equal to 0. Number 3, the limit of f of x as x approaches a is equal to positive infinity, where f of x can be arbitrarily large. Number 4, the limit of f of x is equal to negative infinity as x approaches a. F of x can be arbitrarily small. In here, you have examples. Find the limit 1 to 10 and 11 to 12. I will show you the solution, finding the limit of this problem in the next video. Lesson 2. Derivative, rate of change, and slope. A derivative of a function, f of x, is the ratio of the increment of the function to the increment of the independent variable when the latter increment varies and approaches 0 as a limit. Consider y equal f of x and taking the increment on both sides and denoting delta x as the increment in x and delta y as the increment in y. Hence, when y is equal to f of x and making y now equal to y plus delta x equal to, instead of x, you now write f of x plus delta x, then transferring y from left side to the right side, you now have delta y equal to f of x plus delta x minus y. Since y is equal to f of x, you now have delta y equal to f of x plus delta x minus f of x. Next, dividing everything by delta x, you now have delta y over delta x equal to f of x plus delta x minus f of x over delta x. Delta y over delta x is the measure of the rate at which y is changing with respect to x for the interval delta x. Suppose x is regarded as fixed and then let delta x vary and approach 0, then the limit of delta y over delta x as delta x approaches 0 is equal to the limit of f plus f of x plus delta x minus f of x over delta x as delta x approaches 0 is the rate of change of f of x at x. Therefore, dy over dx or dy dx is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0 is equal to f prime x. The process of finding the derivatives of a function is called differentiation. To find the derivative by limit process or increment method, use dy dx is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0 is equal to f prime x. The notation dy dx is treated as the derivative of y with respect to x, or simply dy dx. Other notation used to denote the derivative of y equal to f of x are dy dx, this is in Leibniz notation, f prime x in prime notation, f or y prime again in prime notation, the derivative of f of x over dx, or the derivative of f of x with respect to x in the operator d sub x y and df dx. Next, in this example, you have a graph with the line, the red colored line, the blue colored curve, y is equal to f of x, and the green line is the tangent line. The point of intersection between the line, the tangent line, and the curve, point P and point Q. The coordinate of point P is xy, while the coordinate of Q is x plus delta x and y plus delta y. Okay? So you have the line delta x and line delta y. Okay? So next, let P and Q be any two distinct points of the curve y equal f of x. The line PQ is a second line. PQ, okay, the red line. If P is fixed and Q is made to approach P along y equal f of x, so Q will approach P along the curve. The second line PQ approaches a definite line PT as a limit. Okay, so this line is called the tangent line to the curve at point P. Let y equal f of x be the equation of the curve, and let xy and x plus delta x, y plus delta y be the coordinates of the points P and Q. From the figure of the line of the slope of the second line PQ is RQ over PR, or delta y over delta x. So this is delta y over delta x, or QR over PR. Okay, next, since the slope of the tangent line PT is the limit of RQ over PR as Q approaches P, that is, delta x approaches 0. Okay, then the slope M of the tangent line at point P, x and y is dy dx. In this slide, so you have the six examples. Solve for the derivative by increment method for numbers 1 to 4. Then for problem number 5, an application of the first derivative, find the slope of the tangent line y equal x cubed minus 3x at point 1, negative 2. And for number 6, find the equation of the tangent line to the graph f at the given point.